Hey, welcome back, all you sixth grade super all stars. So, we're working on prime factorization. And if you haven't looked at the definitions, a prime number is a number that is only divisible by itself and one. So, like 3 would be 3 times 1, and nothing else goes into 3. Or 5 or 7. But 9 is not a prime number because 9 and 1 and 3 times 3 is 9. So a prime number has to be a number that doesn't have any other numbers that go into it except for itself and 1. So we're looking for the prime numbers that factor out of 48. And this is how you're going to make a factor tree. And this one is super, super important. It's in your notes under the key idea. So make sure you have an example. So we're going to choose any factor pair of 48 to begin. So you could choose 2 times 24 or 6 times 8. But this one is an example of 2 and 24. So find a factor pair and draw branches. These are your branches. Okay. Circle the prime factors as you find them. Well, I found 1 because 2 is a prime number. Okay. So, but 24 is not. So I can still find out what makes 24. 2 times 12 is 24. So I have my little branches off there, but 2 is prime. So I'm done with that one. But 12, I can do more, right? 3 times 4 is 12, or you could do 6 times 2. So either way will work. So you have your little branches, and you have a 3 over here and a 4 over here. 3 is prime, so I'm circling it. And then 4 is not prime, so 2 times 2. And now I have all prime numbers, and I can't go any farther. There's another way to do this same, but you're gonna write it out as 2 times 2 times 3 times 2 times 2, which is 2 times 2 times 2 times 2 times 3 equals 48. So if I go in order, 2 times 2 is 4, 4 times 3 is 12, 3 times 2, or 12 times 2 is 24, times 2 more is 48. So there's another way to do it. Like I said, you could do 6 times 8, or this one it's 3 and 16. So you have 3 times 16. Well, 3 is prime, so I circle it. 16 is not, so I'm going to say, oh, well, what makes 16? 2 times 8 makes 16. 2 is prime, so I circle it. Well, 8's not, because I can do 4 times 2, circle my prime, and then 2 times 2, so I circle those as well. So notice how I came up with the same exact answer. 3 times 2 times, I have 4 2's and 1 3. That is a prime factorization of 48. You can also write it as 2 to the 4th power, right? Because you have 2 times 2 times 2 times 2. 1, 2, 3, 4 of them times 3, which shortens it up a little bit. So multiple ways to do the same thing. So we're going to write the prime factorization of 45. I'd like you to try that. You can use this last one as your example, but write down 45 and start making a tree. Go ahead and pause your video.
Write the
And
prime
when you're
factorization of
done
45.
attempting it, here's your
Choose any
example.
factor pair of 45 to begin the factor tree. 45 is equal to 5 times 9. So write this factor pair and draw branches. Circle the prime factors as you find them. 5 is prime,
You could have had 15 times 3.
but 9 is composite. Keep factoring until each branch ends at a prime factor. 9 is equal to 3 times 3. 3 is prime. So this is one way to write a factor tree of 45. So 45
This is a nice and short one.
is equal to 5 times 3 times 3, which is equal to 3 times 3 times 5, or 3 squared times 5. So the prime factorization of 45 is 3 times 3 times 5, or 3 squared times 5.
There it is. Good job on